electricity lecture. This is a electricity lecture. We are starting now. I am hoping that all of you are ready to understand this lecture. uh, as you can see in front of you, there is a slide. In this slide, what is happening here? These electrons are working, or we can say these electrons are moving from one place to another place. Here, look at here. An instrument called ammeter measures electric current in a circuit. This device here, you can see a letter is printed on this device, a, which means ammeter. Name of this device is a ammeter. Name of this device is a ammeter. Okay, now what is the work of this meter, this device? Work of this device is to measure electric current, okay, in a circuit. It is used in a circuit of electricity. And anybody wants to know what is a measure of electric current which is flowing, then with the help of this device, that person can know. So here, ammeter is a device that is used to measure electric current. It will tell you, yes, this much electrons are passing within this much time. Okay, in 1 second a lot of electrons are passing. Then you are understanding, yes, this is the fastest of the electrons. In 1 second some electrons are passing. You will understand, yes, electrons are working slow. So fastness of the electrons and numbers of the electrons you will be able to find out from with the help of this ammeter. Just understand, yes, this is a meter. It is used to measure electric current. You will see voltmeter also. The electric symbol we use to represent ammeter in a circuit is shown in this figure. This is symbol, not this symbol. This symbol is of a bulb. For a meter device, we will use this A. Like that we will denote to represent ammeter in a circuit. Clear? Whenever you are observing like that symbol, you need to understand, yes, this is a device which is a ammeter, and it is working to measure electric current. Clear? Yeah, it is between the circuit. Now electrons will come and electrons will pass through this. Then it will start measuring. Now next we have unit of electric current is ampere. Electric current. So unit of electric current is ampere. Okay, ammeter is used. Look at here, ampere and ammeter both are different. Here ampere is a unit of electric current. Here ammeter is a device. It is used to measure electric current in a circuit, we know. Okay, now next we have electric current and circuit. NCERT problem. We have studied about current in a previous video. Yeah, let's solve a question based on the concepts we just studied. Rate of flow of charge known as current. Rate of flow of charges. What is a flow of electrons, charges, positive ions, negative ions, all this. So flow of water is known as water current. Same here, flow of a charge will be known as current. Here we can write it mathematically like I is for electric current is equal to Q is for T is a time and Q would be charge. Q is for charge. I is for electric current. Here we have a first question based on the concept that we saw. A current of 0.5 ampere. We know that unit of current, electricity current is what? Ampere. So a current of 0.5 ammeter is drawn by a filament. Is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge. Find the amount of electric charge and that follows through the circuit. We have given I is equal to 0.5 and time is 10 minutes. We will convert it into seconds. It will become 60. 10 multiple 60, so 60 seconds, and it is telling you find the electric charge, which means Q. So Q would be Q is equal to I multiple T. So 10 multiple 5, it will give you 50. 60 multiple 1, so by 10, 600 seconds. Now it will give you 50. We will multiply this by this, then we will get this much. We get the value of a charge is this much. That is how. Just to use this formula, you will get this Coulomb charge. Electric potential and potential difference. We have two things. First is electric potential and second is the potential difference. Both are linked to each other. Let's try to understand electric potential and potential difference with the help of the activity. We have this. Don't worry, you will be able to understand this. This is not difficult, but just you will have to visualize it very carefully. Your focus should be on here just for a few seconds. Here, look at here. We have a two beaker, and in this beaker, I think we have water, some water in the beaker. At this much level, you can see. Now a pipe is connected to each other. You can see this pipe is a straight pipe. A straight pipe is connected to each other. Now what will happen? Will level of water of this beaker will come down? No. Level, height of both are same. Level of water of both are same. In that case, nothing will happen. Will water flow? No, because of everything is the same. That's why nothing is a difference. No, because of water level in both beaker is the same. So there is no water level difference. So water will not flow. This level of this and level of this both are same. That's why if the level of this is more and this is less, so this would be known as a difference, and this in that case this level of water will go in this beaker to become equally. How will you do it? Just you can change height. Here height of this beaker is above, and this is the downward. This is upward and this is the downward. Now this will be able to follow. This water in this beaker will be able to follow in this. Will go in this, and you can see this is filled. This is filled, and this is like that. Something you will see difference. Here you are observing what height is a difference. Here height of both are not same, both are different. That's why water will fall. Have you ever thought about why this happened here? The height difference causes, yes, a pressure difference causes a pressure difference between the water in the two beaker. When a height difference will be there, then pressure will come. Here it has a more pressure. Now this water is going in this beaker because of it has a more pressure. That's all. In similar way, there have to be some factors that make the current in a wire. We can connect that difference water level in this. We have here here we have a copper wire. In this, if you have a copper wire, do you think that electric current will follow? That electric current will follow through it on its own? No, because there nothing that is triggering the changes to move. Okay, so what is the factors that trigger the flow of electric charge? We see the term potential here. Have you heard this term before? Potential energy. Yes, it gains, a body will gain energy. That is what is a potential. A body will gain energy. That is what is a a body gains energy, and that body, if that body is ready to, when that body will be released, then that body will come into motion. Here height, you can see height. This height, this is the reason, height is the reason the body gained energy, and this gained energy is a potential energy, and this body gained potential energy because of a height. Now when this object will be released, then it will work, it will do something. Here you can see, when it was released, then it came into motion, and now finally it is at a ground level. When it is moving, then we can say this is a kinetic energy. Potential energy is converting into kinetic energy, and when this object will be released, then we can say potential energy is being converted into kinetic energy. Finally, now this has a kinetic energy, but right now it has a zero kinetic energy. not completely but approximately. Similarly, there is a concept of electric potential energy. Electric potential energy, just like ball in our hand, just like ball in our hand has a potential energy. Similarly, negative charge close to another negative charge has a high potential energy. Yes, yes, yes. As we know that if uh, there are two charges and sign of the both charges are same. If both charges are same, then in that case what happens? If both charges are same, then of course both will repel to each other. We can say both has a, but both has a potential energy. That's why both has a potential energy. That's why they will be repelling to each other. Okay. Here potential energy of this ball was high, but here it became low. It is never ending. Okay. If left free, negative charge gets repelled by another negative charge and moves towards the positive charge, just like a ball falls towards the earth. Yes. What is the potential energy then? It is the electric pressure. It is the electric pressure between two points. This difference may arise due to cells. It is also referred to as a voltage. We have this. You know that this is a positive tunnel and this is negative tunnel. Electric pressure between two points. Yeah, this one and this two points. We define the electric potential difference between two points in an electric circuit carrying some current. Here, two points they both are carrying current Vina as the work done to move a unit charge from one point to another, and they are moving from this side. You can see here electrons are coming, some electrons are going in this and some electrons are going in this. These are two points. These are two points. Work done to move a unit charge from one point to another. From here, some electrons went this in this point and some in this. Potential difference between two points. Formula for this is what? Work done upon charge. Unit of work done. Unit of work done. We know that unit of energy is also joule and unit of work done is also joule. For work done we represent work done as a W, and for charge we represent as a coulomb, Q by Q. Unit of a charge is a coulomb and unit of work done is a joules. To represent charge we just write this Q in capital. Okay. Next we have the SI unit of electric potential difference is a volt. Electric potential difference. Remember, whenever difference word is coming, it means there are two points. There are two points. That's all. Difference will come. It will be possible when there would be two things. Then yeah. Okay then. Okay, so SI unit of electric potential difference is a volt. Okay, and named this is for you. Whatever is given here. Now here look at here potential difference. This is a formula is equal to energy upon charge. No. And for volt is equal to joule upon coulomb. Okay, this is for you. Yeah, remember 1 volt is equal to 1 joule upon 1 coulomb. Yeah, this 1 volt. 1 volt is the potential difference. This is the potential difference between 2 points in a current carrying conductor when 1 joule of work done is done to move a charge of a 1 coulomb from one point to another. Don't ignore this, yaar. Just understand, yes, that this 1 volt is equal to 1 joule upon 1 coulomb, and uh, you will see use of this in numericals. Okay? In numericals, don't panic. Just use this in numericals, and we will see. Okay, we will pick up this in numericals. Don't worry. Uh, in details right now, I cannot say anything more about this. Just I can say yes, this is a formula, and it is telling you that 1 volt is equal to 1 joule upon 1 coulomb. That's it. That's it. Nothing more. In details about it, we will discuss it later. Now we will try to understand by which instrument electric potential difference is measured in a circuit. Okay, instrument. Let's see. To measure electric potential difference, I think it should be voltmeter. Yeah, this voltmeter. Here you can see V. V represents volt. V represents to voltmeter. Here this voltmeter. So potential difference to measure potential difference, electric potential difference, we use a voltmeter device. This voltmeter device will tell you what is a electric potential difference. Okay. Work done in a moving a charge from one point to another is called potential from one point to another point. This will be work done, and this work done is called potential. Unit of electric potential is a volt. We know voltmeter is a device that is used to measure electric potential across 2 points. We are familiar. Yeah, we have some question based on this concept. We have studied about a potential in a previous video. Yeah. Let's do a some example which is based on this concept. Okay. Electric potential difference between 2 points in an electric current carrying some current. Yeah, we can write it mathematically like V is equal to W is for work done, Q is for coulomb, V is a volt. How much work is done in moving a charge of 2 coulomb across 2 points having a potential difference of 12 volt? Volt is given 12. Work we don't know, and coulomb is given to C. Just B is equal to W. W is not given, V is given, Q is also given. So just substitute whatever is a given value. Okay. Here Q is given, V is given, W is not given. So just multiple V by Q, you will get work done. 24 joule. This much work was done. So we get the value of work done to moving a charge of 2 C is 24 joule. Now next concept we have is that electric circuit diagram. Electric circuit diagram. Are we not familiar? We are familiar, yeah. My mind is saying that it would be different from our discussion. But let's see. Will it be different? This is circuit. Yeah, we know. In this circuit, we know that there are some electrical components. First is wire. In this wire, electrons are working. This is switch work of this switch, as we know that it blocks, it breaks the closed circuit and it completes the broken circuit. Yeah, you know. And this is a switch which is a safety device to use, and we know that control of electricity is in our hand when we use a electric switch. So this is useful, it is not useless, it is not a useless. Okay, here this is one wire, one electric component is one wire, second is a switch, third is a bulb, fifth is a battery. Okay, here this flow of electron, it is going like that, but flow of a current would be opposite, like that. Clear? Flow of a current would be like that, flow of electron is like that. Okay, we know that circuit diagram consists of a cell or battery, key electrical components and connective wire. Yeah. Without all this, it is not possible to create any kind of a circuit. Yeah, it is not possible. At least we should have two or more, not only two, three or more. You can say three or more electric components, so that we can create a better circuit. Even you can say in this, if we remove this switch, then we will have three electric components. If you remove a wire, then it will be 100% impossible to create a circuit. Okay? Now next, in this video we will learn about electrical symbols of electric components. Look at here, this group of cells. Remember, if you take a group of cells and combine ends of each cells to each other properly, combination should be correct. Okay, joining of a wire with the ending of the each electric cell should be correct, then it will work. Look at here, now you joined each wire with the ends of each electric cells. Now what will happen, this is your, now this is becoming your battery. Okay, it is a formed battery. So definition of a battery is a simple, just a collection group of electric cells with joint by wire properly will be your battery. Here we have this cell, this bulb, this emitter. We know that this is a device which is used to measure electric current, and this is voltmeter, which is used to measure electric potential difference between two points. We have this 4. We will use this 4 to create electric circuit. Look at here. It is often convenient to draw a schematic diagram in which different components of the circuit are represented by the symbols conventionally. Okay, you can ignore this long sentences, but we will visualize it. Conventional symbols used to represent some of the most commonly used electric components. Look at here. Listen to me. Anytime you cannot use just a long words. You cannot write this is a electric bulb, this is a electric battery. No. Rather than writing, you can write a letter to represent. For example, to represent a meter device. Okay, a meter device. Just draw a circle, and inside the circle just write a. Okay, Now people will be able to interact with this. People will say, yeah, yes, this is a diagram of ammeter device, ammeter device. So rather than writing ammeter, this is a device, it will measure electric current. No, just about this. Okay, just draw a circle and inside this write a word, a letter, not word. Do same with the other. For bulb, what is it looks like that. Okay, like that. This, this, like that. Okay? Symbols of different. There are different symbols of a different electric current, electric component. Okay, do you recognize this? What do you call it? Yeah, we know that this is nothing but electric cell. Okay, electric cell. Here, look at here. Voltage in this cell has how much? 1.5. In this 1.5. Yes, you recognize it. This is electric cell. Now we know that this metal cap. It is a cap and it is a flat disc. So this is a metal cap. We know that this is known as a positive terminal and this flat is known as a negative terminal. And here is hint symbols of negative and positive are printed over here. This negative, this negative, this negative. We are able to identify, yes, this is a positive terminal and this is a negative terminal. Okay. How will you draw symbol of a cell? For symbol, for erect, what should be symbol? What should be symbol for electrician? So this here, look at here. This big, this height, this large will be for positive terminal and this would be for negative terminal. Remember, okay? A small for negative terminal and big for positive terminal. Clear? This is a symbol for electric cell. Don't forget. Now here you can see there are two electric cells and both are connected to each other. In that case, you say here, yeah, this is forming a battery. Yeah. Now both are together and it is giving you how much voltage? 3 voltage. 3 voltage. It is not too much, but 3 voltage it is providing them. What else can we expect? Now join the positive terminal of one cell to the negative terminal of the another cell using tape, and like that you do with the 4 cells, 5 cells, then you will be getting more voltage. Clear? More voltage. Now is it called a cell? No, this will be battery because it is a group of electric cells, not a unit cell. Okay. Battery is a combination of 2 or more cells, not one would be known as one would be known as electrician, but when it will come to 2 or 3 more with and all these are connected to each other with the help of wire, then this will be known as battery. Now next we have, can you draw the symbol of a battery? Yeah, we know what is a symbol of electricity, but what is a symbol of a battery, for battery? So I think these positive, negative. We will draw symbol of battery in a circuit like this. Okay, this is symbol. Clear? Which electric component do you use to on or off the light? You know, electric switch. I have told you, I have explained it. Okay, where it gives you safety. You have a control of electrical circuit. You can break the, not you, but directly indirectly you are breaking the closed circuit, you are completing the broken circuit, but by using switch. Okay, so switch, you know that switch breaks the closed circuit and it completes the broken circuit according to requirement, according to me. 3. What is the symbol of a switch? It looks like that. For switch on, it will be connected, but for switch off, it will not be connected. Here you can see this is symbol for switch off, and this is symbol for switch on. Here, look at here. We also use another symbol for plug key. This is telling that plug key or open switch. This is a open switch, and this is a closed switch. Okay, this is open switch and this is a closed switch. Just a point in this, try to understand. We know that this is for battery, not battery, this is a cell, and it is a bulb, and this is a what? It is a switch. We know that this is a open switch. In that case, this will not glow, bulb will not glow, you know. And here, what is happening over here? This is the on switch. In this case, bulb will glow. Everything is one. Everything is connected. Is a fine. That's why bulb will be able to glow. Okay. Now next, can you draw the circuit diagram of the circuit? Yeah, this is a circuit. This diagram used to when switch is off or on. We are familiar with this. This is wire. This is electric wire which we use in electric circuit to connect components. Yes, we know. If two wires are connected like this, which symbol do you use? Like that. If two or more wires connected at a point, that is called a wire joint and is a sound like that. It is telling that there are two or more wires which are joined to each other. This is an incorrect way to represent. Is this a wire joint? No, because two wires have two physical contact. They are just crossing each other. Wire crossing is represented in a circuit like this. Now, let's try to understand about the resistance. This is new. I was getting bored with the discussion of electric circuit diagram. Now, resistance. Let's try to understand about resistance. Can you explain about it? Do you have any idea to explain this resistance? Most of you would say, "Yeah, this stops." Okay, work of this resistance is to stop something. Yeah, you are correct. Okay, you are correct. It can be extended more. Let's extend. Resistance is represented by this symbol in electric circuit. Look at here. Resistance is represented by this symbol. This symbol is for resistance. This resistance. The resistance which value can be changed is called variable resistance. Here 10k, 30k, 50k, 20k, 90k, all these are changing. So this will be known as variable resistance. Here k is coming, that's why variable change. We use this symbol to represent variable resistance in a circuit. Okay. Yeah, these are components and these are symbols of these components. These are for you. For ammeter, just A, and for voltmeter, just B inside the circuit. Variable resistance or resistor for this a resistor or a resistor of resistance are for this is for this electrical, like that. Okay. Next, learning objective. In this we are going to start with the introduction of Ohm laws, then we will see Ohm laws. Then we have NCT problem on the concept of Ohm's law, then factors affecting the resistance, then NCT problem, then resistance of a system of resistance. Now we have all this learning objective that we will be discussing together. Then next we have more, which is resistors in series, NCT problem, then resistors in parallel, then resistors in parallel NCT problem. Practical uses of a series and parallel circuit we will see. Let's start. Yeah. Now we are starting with the introduction of Ohm's law. The introduction of Ohm's law. We have studied about circuits and current, but we don't know yet what rules govern the flow of electric current. Okay, let's try to know. This pipe, yeah, height is the same, water level is the same, nothing will happen. Let's look at this situation which we have seen in the early video, that two beakers are connected with a pipe. Pipe is straight. Water level is the same. Height, there is no difference in height. In that case, water will not flow from one beaker to another beaker because of everything is the same. Nothing is different, that's all. But in this case, one of the beaker placed at height above the other, and the water will flow. Now water is flowing because of there is a something different. Difference is that height difference. That's why water from a beaker which is at height will flow in another beaker which is downward. Okay. That is how difference works. And this is known as height difference. Okay, this is known as height difference. What happens if we increase the height differences? Then more water will go in another. If we increase the height of the beaker, flow of water will be faster. Wow, it will be more faster. If height will be increased, then faster, then flow of water will be fast. Yeah. So here we are saying, yeah. Theory. If is directly proportional to H. Now look at the another factor. If I make a pipe thinner, what will happen? Then fastness will be more. Fastness will be more. So thin. The thin pipe will allow only a small amount of water to flow through it, and hence the rate of flow of water will be lesser. Okay. Now we can say that flow of water is directly proportional to the height and inversely proportional to the thickness of a pipe. What the hell? What the hell? What the hell is happening here? If hold on, follow. If is a follow, okay. Flow of water is directly proportional to height. Okay, height. If height is increasing, then flow of water will increase. Okay. But if flow of water is increasing, but thickness of the pipe is if we decrease thickness of the pipe, then flow of water will decrease. What are you understanding? You are understanding that if flow of the water, if thickness of the pipe will be decreased, then flow of water will amount of water will decrease. Okay. But if height is increased, then flow of water will also increase. Looking at these two relations, we can say flow is equal to H upon T. Between this, flow proportional to height, and inversely proportional to the thickness, In that case, what is happening? This will come here, and this as it. F is equal to H upon T. This activity is analogous to the Ohm's law, in which we can say flow of water is analogous to the flow of current. Here, ignoring the constants. What is happening over here? Ohm's law. This V, this V, this one and this is second, V upon R. Here we are saying, we can see that the current through a resistor is inversely proportional to its resistance. It is telling you if current will increase, then voltage will also increase. But when current will increase, then the resistance will decrease. That is what it is trying to tell you. When current will increase, then voltage will also increase. Then in the other case, if the current is increasing, then the resistance will be decreasing. That's why we are saying current is directly proportional to volt, and current is inversely proportional to resistance. Here you can see voltage increasing, then I will be also increasing. If the potential difference between two points will be more then current follow through it will be also more. Here look at here, if resistance is more then current I think it should be less. Current through conductor will be less, yes, because resistance is more. Resistance, here look at here, what is happening, resistance is coming. So of course this follow will be less, follow will be less, follow of the water will be less because of resistance is coming. Clear? If resistance is more then current will be less, if resistance is less then current will be more. Simple. Flow of water is analogous to the flow. Height difference is analogous to the difference between, okay, thinness is analogous to the, this is for you. Ohm's law. We have discussed about Ohm's law in the previous. Let's try to understand something else. Let's do an experiment to understand Ohm's law practically. You can also do this experiment in your physical lab. This is a experiment. Nichrome wire. Okay. Ammeter device, we know that. Electrician, we know. Voltmeter, it is a device, we know. One thing more is that nichrome wire 3 electric cell for low voltage. Wave from circuit like this, which has just one cell has a as a source cell. This is cell, we know that this is cell, and this is nothing but nichrome wire. This is a nichrome wire which acts as a resistance also. Okay, this is a resistance, we know. This is a voltmeter, this is a ammeter, this is a cell, this is a plug, it is an open switch. This is wire, this is a cell, this is a nichrome wire, and we can also call it as a resistance. Look at here, this volt here, one point is over here, one point is over here. That's why this is a ammeter which is connected in series. Where is the ammeter here? Ammeter. This is voltmeter which is connected in parallel. This voltmeter is connected parallel. This is a plug key. Yeah, we know that. We close the plug key and note down the same reading. We need to note down reading in a voltmeter and a ammeter. Let current 1 and potential difference across the wire be V1. Two cells. In second case, connects two cells in series in this circuit and note down reading in a ammeter and voltmeter respectively. In this case, we have two cells. Okay. What is happening over here? Ammeter gives the value of current through nichrome wire, and voltmeter gives the potential difference across the nichrome wire. Now what is happening? I have two V2, two cells. Now we have three cells. Nothing is happening. I is increasing, V is also increasing, and as we are increasing cells, but are they increasing proportionally? So we calculate the ratio of V upon I. Okay, V is directly proportional to I. Can you draw graph between current and potential difference with the help of Ohm's law? This is a diagram. Thus I graph is a straight line that passes through the origin of the graph. Thus Vi is a constant ratio. This will be volt and this is the ammeter. If a volt is 1, then ammeter will be 1. If a volt is 2, then ammeter will be 2. If a volt is 3, then ammeter will be 3. If a volt is 5, then ammeter will be 5. Just like we saw in our activity. The potential difference V across the ends of a given metallic wire in an electric current circuit is directly proportional. This is called Ohm's law. Provided its temperature remains the same. In the other words, V proportional to I and V upon I is equal to constant is equal to R, V is equal to IR. So it is telling you that R is a constant. Okay, R is a constant. V upon I will be constant. Why constant? Here we are saying V upon I is a constant. As we saw in the graph that graph of this V upon I is just a linear which starts which was going crossing the origin till the infinite in state. This was a state. It was giving a constant. It was giving a constant. Linear. So V upon I is equal to resistance R. R is a constant for the given metallic wire at the given temperature and is called its resistance. It is the property of a conductor to resist the flow of charges through it. Here, look at here. We have this electron and this is volt. Voltage is coming from this side. Voltage is coming from this side. Okay, and electrons. These are electrons. Current. Direction of a current is in this. It should go this side. It should go this side. But resistance is not allowing to pass this this electrons. That is how resistance works, and it is a property of the conductor, not to another. SI unit of a resistance is a ohm. SI unit, Ohm's law, represented by the Greek letter. SI units volt, for voltage volt, for current ampere, for resistance ohm. Define 1 ohm. Okay, 1 ohm is equal to 1 volt upon 1 ampere. 1 ampere. If we need to increase or decrease, if we need to increase or decrease the current in a circuit, resistance helps us do that. What? Here we have 3 ohms. This is a 12 voltage. This is 12 voltage. In this we have 6 ohms. So what is happening here? We need to increase or decrease current. The current in a circuit. Resistance helps us do that. 12 volt. A component used to regulate current without changing the voltage source is called variable resistance. This is variable resistance. Variable resistance is shown in a circuit is like that. Here variable resistor symbol. In an electric circuit, a device called a rheostat is often used to change the resistance in this circuit. Terminal A, terminal B. How much current will an electric bulb draw from a 220 volt source if resistance of the bulb filament is this much, 1200 ohms, this much resistance? Then how much current will an electric bulb draw with the help of this much voltage? We know that R is equal to V upon I. V is given, I is not given. With the help of, so V is given. So I will be, I is equal to VI. This will give you I. I is coming as a 0.18 ampere. So we get the value of the current is a 0.18 ampere. Resistance is the property of conductor to resist the flow of charges. The flow of charges is the property of a conductor to resist the flow of charges. Here what is happening? Resistance is stopping the flow of charges, not completely, but it is a stopping. It is a trying to stop. Okay, so flow of charges will be slow. When resistance will come to work. Okay, so here it is decreasing the flow of electrons. Who is increasing? Who is decreasing? The resistance. If resistance will increase its power, then flow of the electrons will decrease. will decrease. If it is a more, current through wire will be less. If it is less, then current through wire will be higher. Look at here, 3 ohms, more, less ohms, less resistance. So current is a more in this, but in this resistance is more. That's why here current is follow of a current. Okay, follow of a current is a less. Actually, it is inversely proportional to the current. Let's talk about the factors on which resistance depends. Let's do a small experiment to understand this concept. Take a small electric circuit like this, which has a cell, ammeter, and plug key. Okay, ammeter. Here nichrome wire. In case 1, length. Okay. Now change the length of wire. We do it length the previous length, but we keep its thickness same. Now thickness is more. Now let understand result case by case. We see that length of wire increases, the current reduced by same factor. It implies that current is inversely proportional to the length of wire. More length, resistance will be more. More length, then resistance will be more. Wow. So we can say resistance of a wire depends on one factor, that is the length of the wire. Yes. The third case tells us that if the thickness of the wire increase, the current through wire also increase. Yeah, thickness, because electrons will come more. Thickness. I is directly proportional to ammeter. So we can say current is directly proportional to the cross section area of the wire. Which means R is inversely proportional to the cross section area of the wire. Yes, R is inversely 1 upon A. Combining these two, we can say R directly proportional to length I, but inversely proportional to the area A.